My name is Lee Calcote. I'm going to talk about microservices, sockets, NGINX, and a little bit of Kubernetes sprinkled in there. A few buzzwords for you guys. I wanted to call out to my partner in crime on this, Yogi Porla. He's not joining us today, but without him, this presentation wouldn't have been possible. Speaking of the presentation, if I go too fast or you want to dig into some of the notes later, these slides are available at that URL, so feel free to go there. So enough about Yogi, let's talk about me. One of my favorite topics. Various ways you can harass me online if you don't get your chance in this talk. I'm into a few different things. I host a couple of meetups here in town, which is why I get to know some of you guys. I also do a bit of writing, a little bit of analysis, essentially make something of a nuisance of myself in various ways. I was up at ContainerCon presenting a little over a week ago, and one of the places that I write for is the New Stack. They just released the fourth installment of their ebook. So if you want to know about container security, storage, or networking, I'll say that the networking chapter is particularly juicy. That was mine. Also authoring a book on CoreOS Tectonic and Kubernetes, and so most recently have joined up at SolarWinds here in town. So quick show of hands, how many of you guys know SolarWinds, use its software, love its products? That's pretty much everybody. That's pretty much what I thought. Yeah, okay. Right? Yeah. All right. Cool. I'm happy to receive that positive feedback when we're done. Nice. Well, good. So another thing I'm trying today is to just get a rise out of you for one, but for two is to see if I can't use my phone to slide through things. I tried to do this a week ago, got a couple of phone calls at the same time, and the whole presentation went to crap. So let me set this up and talk about the app, our case study today. Thank you. You guys know this app, right? You guys have seen this app. Sometimes it's out on the beach, and other times it takes the shape of like a 1 gigabyte jar file. Man, it's all just monolithically stuffed in there. And so I guess point being is careful what you feed your app. In this case, not only was our app a 1 gigabyte jar file, but it was a piece of software written by a small startup here in town, MaxPlay. They are a game development studio, moreover a game engine/design studio. So they end up creating really collaborative game development environment that game designers use collaboratively. So they're trying to really build sort of a Google Docs for game development, so such that as you're creating a new sprite or putting in a new, you're working within a scene and you change the lighting or you change the color of an object or build out, you render a new object, that you do so in a collaborative kind of real-time way with others who would be working on the same game and same design with you. So if we take a look at their bloatolith as it was previously, this is for the most part what it looked like. I'm going to do my darndest not to walk over and just hit the slides. Okay. But a couple of things to note. Very clearly and obviously, the lightning bolt means connectivity, right? Isn't that what lightning bolt means? Anyway, the point of it is a number of game design specific services up in the cloud. In this case, this cloud was Google Cloud Platform, so GCP. A couple of interesting frameworks that were being used, Vertex for reactive services that were offered. Hazelcast is in there, and SockJS. Initially, the GCE network load balancer was being used. These web-based or these cloud-based services were tethered to or joined up with some services hosted on-premise. These services were about, it was a big data deployment about analytics. So both analytics around telemetry in terms of how people are using the design software, as well as once games were published, the manner in which games were being played and what features were being used. And so these two systems worked in unison. One thing to take note of is that really that 1 gigabyte jar file that I was talking about, it's really contained within that single instance that you see there. And so as you needed to scale up, or really, I guess I just said it, like as you need to scale up, you don't scale out, you kind of scale up here. You recreate that instance, and you have multiple of those. And that seemed to work well up to about 10 users. And then performance started to go downhill. So just, really something needed to be done there. And so to kind of set up that challenge, we took note, we need to take note that our app is reactive. So we talked about Vertex and the notion that really in order to deliver the type of experience the application was intended for, it would, it would be very responsive, be very reactive. There'd be a lot of eventing happening. The game designer would make a change to the lighting of a scene, and that would need to be maybe re-rendered or recooked, and that event sent over to another user in a remote location who's working on the same scene, so that you could collaboratively design that. And so there were some real needs around performance and making sure that the way in which the application worked was extremely low latency. Also, some challenges around distribution of content. Some of the content are the objects that I just talked about, like a Maya object that was rendered. Other content was audio or video that was part of the game that you were designing. Some of the video ended up being like 4K video, and so obviously a lot bigger. We're not going to solve all of the challenges today, but just good things to understand as a backdrop to how it is that NGINX and other technologies came to bear. Part of, I think a good thing to note here is kind of the softer side of the challenge, which was in and around the engineers that were that were at MaxPlay and kind of their heritage. How much DevOps/cloudy chops did they have? How much? A lot of them came from more enterprise architected software, and so that made sort of moving to microservices and moving even more into cloud and into more of the managed services there, kind of a scary proposition. Change is not always fun. So we start to shape up this app. So that's kind of where we were. Those are the challenges laid out before us. Real quick, I'll digress and just how many, just a quick sense of it. Just I have a meetup here in town on microservices and containers. How many of you guys are just into this general land and kind of feel like you've got your own definition of this term and sort of or are venturing into that? Okay, all right. So again, just like all of you. Okay, that makes sense. That's kind of what I expected. Okay, great. Because these have been around forever, and anyway, in some respects they sort of have with SOA and other. Anyway, I figured we wouldn't go through defining these things. That you get enough of that in other talks, I'm sure. A couple of, I think, interesting questions to ask yourself as you go to characterize whether or not you're doing microservices right, or doing things that sort of look like a microservice. Obviously, microservices are small. They're autonomous units, autonomous pieces of function. But what is small? I think we have an easier time defining, we have an easier time kind of feeling out when something is big. I said a 1 gigabyte jar file, and I think that you guys sort of reacted in the same sort of, I don't know if it was the picture on the screen or just sort of, your reaction to that. But we have that good sense of when something's too big, but how small is small enough. And I think part of the tests that you can start to ask are whether or not a small team can manage that whole microservice. So yeah, other tests there are, whether or not you can make a change. Is it another characteristic of a microservice is whether or not it's autonomous and can function unto its own, have its own versioning and lifeline. So one of the tests there is whether or not you can make a change to that, upgrade that microservice, version it, and only deploy that microservice or only upgrade that version. So can you deploy a new version of that service without upgrading anything else? I'm not going to go through all these and just say that I think in my mind one of the beautiful things about microservices and also about construction happening while you're speaking is that in microservices you can, there's something of a democratization of selection of technologies and frameworks and languages. which is really nice, because if a lot of that's encapsulated and your contract is on the API that the other services are speaking to, then while you probably wouldn't want to go hog wild and run, Oracle in here and MySQL here and Postgres here and just totally, a bunch of different random technologies, that at least there's some amount of freedom in and amongst the particular team that's that component owner, that service owner. They get to choose kind of best fit technologies or best fit language for the problem they're trying to solve. And then so long as they maintain that contract, that API on the outside, they get to make some choice. So that's one of my favorite benefits about microservices. There's a lot of other things that aren't necessarily specific to microservices, but just maybe continuously delivering and SaaS in general. We at SolarWinds are working at various stages through that. So sort of to the rescue are two of these technologies. So kind of prior, based on some relationships with Google for this particular startup, they had chosen GCP as their cloud of choice. And as we went to break down that bloatolith into smaller microservice-y type components, Kubernetes came as our first choice in terms of container orchestration. And then so did NGINX in terms of handling really just two basic use cases. And these are, much of what we're going to talk about today is actually just very kind of basic functionality. Number one is SSL termination or SSL offloading. And you'd think that by now that would be a pretty ubiquitous capability. And it is getting to be there. Not necessarily entirely there. Kubernetes, for example, actually as of 1.3 or as of its current release, doesn't necessarily natively support that type of functionality inside of a kube proxy. And so that's where a technology like NGINX comes to play. The second kind of use case for us initially was around load balancing for WebSockets, so WebSocket support. And so it's not necessarily well drawn, and that's my fault, but is the notion that we're getting SSL offloading from NGINX, and it's directing and still leveraging the native load balancer of Kubernetes kube proxy, but it's decrypting SSL or decrypting that traffic up front and taking that load off of kube proxy. The second thing it's doing, that higher level black line, goes direct to SockJS, which was the framework that we were using or that this startup was using for socket connections to do that highly performant eventing as someone were to make a change, in one scene and somebody else needed to receive that. So we still have our on-premises big data deployment, but we begin to step into this land. So we ended up, again, very sort of simple capabilities that we were leveraging from NGINX. Also very simple capabilities leveraging from Kubernetes. Things, just what you see here on the slide in terms of pods, services, also a little bit in terms of daemon sets. So just real quick, if you're not familiar with a daemon set, you're seeing authorization as a component in each of those pods, and very clearly black is a pod, if that wasn't obvious. But authorization is just a capability of anytime you want to leverage a service, just that service, that HTTP request needs to be checked and just verified that the caller is authorized to do that. And so we use daemon sets within Kubernetes to say, hey, this capability needs to be on every node that's out there. And so, yeah.
NGINX also does authentication. Why you guys chose not to?
The authorization, so in this case, great point. So I'll clarify between kind of authentication and authorization. And maybe that was clarification enough, but just that authentication being like sort of confirming who you are, and then authorization just being, hey, the permission set by which you can do certain things within the platform. And so it was just custom code written to. All right, the quick time check is just like the sense that we are 4 minutes out and we haven't. All right, so comparing services. This is where you can come back and look at the slides later, given that we've got 4 minutes left. I apologize. So just, as you go out and look for just support for SSL termination, SSL offloading, you'll find it's a little bit of a mixed bag out there. Things are changing quickly. I said that this particular offering was hosted on GCP. Most recently, there's a beta capability available called SSL proxy. But anyway, your mileage will vary in terms of where you can get that capability, even some of these more, in my mind, remedial capabilities. WebSocket support, again, just sort of a breakdown of who's supporting that now. Probably a little bit better support you're seeing. So yeah, the links are active in case you want to go look up kind of those notes. But really, it's interesting to look at why was it that we chose NGINX versus like kubeproxy and one of those things is the notion that we're dealing in a hybrid cloud scenario where we do have load balancing that needs to happen on premise, some up in the cloud. It's nice to be able to get a consistent administrative interface, be able to use the tools you kind of already know. I think that was certainly an attraction for this team. Also, as they scaled that out potentially globally, depending upon their success, that NGINX Plus would help with some other features we'll talk about in a minute. But also the notion that as they go to run some of these services on bare metal or in VMs or in containers, that they can have that same consistent administrative experience and the same consistent capabilities, in some sort of almost irrespective of what technologies are being used. I'll asterisk that with things in the container space where, depending upon how you're deploying NGINX, you might find different capabilities available. So the way in which NGINX was deployed in the last slide that I showed was as a standalone entity running in its own VM. You can also deploy NGINX as a Kubernetes ingress controller. That's a different talk, and someone else is actually giving that talk. But also the notion that as our teams matured, and back to kind of what I'd said about the skill set of the team that was there, as they matured and began to get more cloudy and began to take more advantage, or began to get into things like, I'm going to skip ahead just based on time, things like content caching or GeoDNS, sort of local, serving up of some of those objects that we talked about before, the audio and video files locally, that they could do that with. NGINX would be there for us as we matured into that. Another use case was just, very simple again, but just A/B testing of helping us trial out some of our new functionality with new users. I know I skipped through that quick. These are things that the team didn't get to, but just trying to reinforce the notion that, hey, having that capability there and allowing the team to grow into it was part of that choice. I'm going to go back here really quick, and this is the slide where I was just saying one of the ways to deploy, as we were to get into kind of the V2 of that micro bloat of that architecture, we would look to get a tighter integration with Kubernetes and NGINX, and that's probably best done through, and Kubernetes has this construct called ingress. It's the way in which network traffic, as it comes into the system, is handled. And you can choose what ingress controller, different types of ingress controllers you can have service that traffic. And in this case, there's an ingress controller for, NGINX as an ingress controller. The nice thing is, if you're using NGINX Plus, there's some native, or not native, but there's a tightly integrated service discovery that happens there. So again, the team didn't need this immediately, but as they go into some of the use cases I showed below, they would. So, yeah, geez, so we actually hit our 20-minute mark pretty quick. We had one question, good one. Probably have time for one more before someone kicks me off. Yes, sir.
Tell me what the DSLV capabilities.
Yeah. Go back. So some.
It's a geomap database in the backend and do the load balancing or global load balancing requests, or how does it? What is the notion here? And is it available now or in the future?
Yeah, good question. So I'll repeat the question and then probably give a very disappointing answer. But the question was, hey, in terms of some of the back-end capabilities, or in terms of some of the GSLB capabilities of NGINX Plus, how are those fulfilled? I think you said, was it config map? A geomap. So I don't know, or I don't have I don't know. But I do know that there are people here who do. So the team didn't step into it just yet, but so I don't have. But sort of our selection of that technology was kind of predicated upon the notion that we would step into that. Good question. Okay, good. Thanks for coming, y'all. Yeah.